can write polynomials in what we call quadratic form, provided it's in the form of a number squared plus a number plus c. In other words, when I have something that can be written in quadratic form, I'm going to have some term. I'm going to have a different exponent for my middle term. That's going to be my constant term, and then I'm going to have a constant. So for example, if I have x to the fourth minus 5x squared minus 14, what I'm going to do is I'm going to let u equal x squared. I guess I got the picture or the work right there. And so then instead of writing x squared, I'm going to write u. So I'm going to say minus 5u, and then to find x to the fourth, I'm going to take u squared. And then we get that term. So what happens, it makes it a lot easier to solve when you put it in this form. So let's apply that to a problem. So here I want to state the number of possible real zeros and turning points for my function. Then I want to determine all the zeros by factoring. So first off, I know I'm going to have at most 4 real zeros. I'm going to have at most 3 turning points. Now I notice I can write this in quadratic form because my middle, it's not a quadratic per se, but I notice x squared is my middle term. So here's what I'm going to do. I'm going to let u equals x squared. So instead of saying x to the fourth, then I'm going to say u squared minus 4u plus 3 equals 0. So now I can factor that. And you're going to find out, we probably could have just factored this anyway by noticing the pattern, but we're going to do it this way. So we're going to say u, and let me see, I have to get a negative 4, so u minus 3 and u minus 1 equals 0. It makes it easier to factor, that's for sure. Then I'm going to say, oh, u minus 3 equals 0, or u minus 1 equals 0. And so u equals 3, or u equals 1. Now I'm going to go backwards. Remember, the way I set this problem up is I let u equal x squared. So I'm going to go back and replace u with x squared. So x squared equals 3, or x squared equals 1. So what I'm going to do is take the square root of both sides. So what happens is x equals plus or minus the square root of 3, or plus or minus the square root of 1, which is 1. I don't know why I'm going to put square root there. I'm going to say 1. So plus or minus 1. So notice what we have here is we have 4 real zeros. 2 irrational and 2 rational. And that's where the quadratic form comes in handy. It just makes working with my problem a little bit simpler.